Hello, everyone. Thanks for joining us today, and welcome to the Online Tech Talk. So today we will be covering the top 7 ways to operationalize AWS Security Hub. So we will provide some guidance and templates to operationalize Security Hub so you can maximize the value that you get from it. My name is Prashop Krishnan. I'm a Senior Technical Account Manager with AWS Enterprise Support. I'm based in Denver, Colorado, and I have been with AWS close to 2.5 years. So today I'm joined by my colleague Jason, who is an enterprise solutions architect. Jason, do you want to say hello to everyone?
Hey folks, my name is Jason Champ. As Prashab mentioned, I'm a solutions architect based here in Cleveland, Ohio, and excited to share some of this with you today.
Excellent. So let's move to the agenda for today. So so here's the brief agenda for today. So we will start by providing an overview of Security Hub. We will then take a look at how to enrich your Security Hub findings with account-related metadata, creating a bi-directional integration with a ticketing system like Jira, how to build auto-suppression rules and correlate findings. We will also show you how to set up automated and on-demand remediation actions, integrating Security Hub with BI tools for advanced visualizations. And finally, we will take a look at how to schedule weekly summary emails and then wrap up with a Q&A section. So first of all, let's take a look at why did we build AWS Security Hub. There are mainly 4 drivers behind it. First is from the compliance perspective. So many customers have different internal and external compliance requirements. And some of these are regulatory, such as HIPAA, NIST, PCI, etc. Some are internal requirements, and some requirements are having industry best practices in place. Irrespective of what the requirements are, AWS customers need a way to track their compliance status and also need a way to ensure that they are adhering to them. Next, AWS customers oftentimes deals with different types of security tools, sometimes dozens of security tools. And each of these tools emits alerts in a different format. As a result, customers have to parse and normalize this data to a common format so that they can research and analyze the alerts and ultimately determine which alerts are most important. Which brings us to the third problem statement. So these security tools generate hundreds or sometimes thousands of alerts every day. Customers need help in identifying which of those alerts are most important and which of them needs human intervention. Lastly, in terms of visibility, customers want a single pane of glass. They want a single place where they can go to understand their security and compliance state. They don't want to pivot around to different screens or tools to understand their security postures. So customers need a single place to go every day to understand what they need to do to improve their security and compliance status. Moving on. So for that reason, we built Security Hub. The way that it works is, once you turn on Security Hub, it automatically starts to aggregate findings and alerts from core AWS security services, such as Amazon Guard Duty, Amazon Inspector, Macie, Firewall Manager, and IAM Access Analyzer. If you have enabled the services in the account where Security Hub is on, we will automatically bring findings from those services into Security Hub. In addition to that, Security Hub also integrates with multiple partner solutions. What is interesting is that both the core AWS services and the partner products send findings into Security Hub in a standardized format called AWS Security Findings format. Because of this, security teams don't need to parse or normalize this data and can start the analysis from day one without any additional setup. Another capability of Security Hub is the automated security checks. Security Hub can proactively do automated continuous checks in the account. Once you enable standards such as AWS Foundational Security Best Practices, AWS CIS Foundational Benchmark, or PCI DSS standards. Finally, Security Hub is not just a visualization dashboard. You can also take actions on findings by making use of Amazon Event Bridge. Events from AWS services are delivered to Event Bridge in near real time. And you can write simple rules to indicate which events you are interested in and what actions to take when an event matches a rule. So it can be like sending to a SIEM, sending to your ticketing tool, or to a full remediation platform, helping you close the loop on that finding. And throughout this presentation, you will see this approach being utilized to build different solutions, which we will talk about in detail in the next slides. Okay, so our first tip of the day is how to enrich Security Hub findings with additional account-related metadata, such as the account name, organizational unit associated with the account, or security point of contact information. Any additional contextual information that you want to add, like whether it's a production or development account, can be added as account tags. The security or the DevOps teams responsible for investigating, responding to, and remediating Security Hub findings may need this additional account metadata to determine what to do about the finding or where to route it. For example, identifying whether the finding originated from a development or production account can be key to understanding the priority of the finding and the type of the remediation action needed. So how does the solution work? So every time a finding is created or updated in Security Hub, it emits an event in Amazon Event Bridge, which contains all the information about the finding. So we'll create a rule in Event Bridge, which will send this event to a Lambda function for further processing anytime a specific condition is met. So the Lambda function uses the account ID in the event to retrieve the account metadata and the alternate account contact information by querying AWS organization and account management APIs, and caches that information in a DynamoDB table for performance. Using batch update findings API in Security Hub, nodes and the user-defined fields attributes of the Security Hub finding is updated with the additional account metadata. So this will now be visible in Security Hub and allows customers to build custom insights to track which organizational units or applications have the most open security issues. All the information required to deploy the solution is available in our blog post, which is on the top right section of the slide, as you might have noticed. So now let's take a closer look at the solution by going into the AWS console. We have a small demo prepared for you. Thank you for joining me in the console. As you can see, I have deployed the solution to my Security Hub delegated administration account using a CloudFormation template. The CloudFormation has created the following resources in the account: a DynamoDB table for storing the account metadata information, a Lambda function which is responsible for populating the DynamoDB table with account metadata by querying the organizations and account management APIs. It also deployed an event bridge rule, which will trigger the Lambda function whenever a specific condition is met. And the rest of the resources are the IAM permission policies for the Lambda function and the event bridge rule. So let's take a look into the event bridge rule here. So whenever a finding gets created or updated in Security Hub, the rule checks for the existence of a specific user-defined field, which is the finding enriched field. And anytime a finding is matching this event pattern, the rule will trigger the Lambda function as defined in the target of this event bridge rule. The Lambda function will then query different APIs to gather the metadata information such as the alternate security contact, organizational units, and account tags. It will then store this information in the DynamoDB table. And finally, the function will also update the user-defined field and also the nodes field of the finding with the account metadata information which it just looked up. So here is a DynamoDB table item containing the sample enrichment text. The Lambda function will actually check the DynamoDB table first before querying any APIs to get the metadata information. This is because the metadata information does not change very often, and we can also reduce the API hits. The Lambda function will refresh this information every 24 hours to make sure that there is no stale data. And in Security Hub console, the enriched information appears in the note section like this. So there is account name, OU name, security contact information, and any other information baked into the account in the forms of tag will also appear here. We can build custom insights in Security Hub using this enriched information by filtering on the user-defined field as shown here. So here I am filtering on the account name. You can customize these reports to your need. For example, you may want to view the findings for your development accounts or your production accounts or your organizational unit as a whole. Then you can use this information for reports or send them for any additional remediation. Okay, so hope that tip 1 was helpful to you. So our second tip is to create a bi-directional integration with an external tool. If you use both AWS Security Hub and an ITSM tool like Jira Service Management, you can use an application called AWS Service Management Connector to create an automated bi-directional integration between these two products that keeps your Security Hub findings and your Jira issues in sync. As a Jira administrator, you will then be able to create Jira issues from the Security Hub findings automatically. And when you update those issues in Jira, the changes are automatically replicated back into the original Security Hub finding. For example, if you resolve an issue in Jira, the workflow status for the finding in Security Hub will also be resolved. So this way, Security Hub always has up-to-date status about your security posture. To get you started quickly, there are sample CloudFormation templates available in AWS documentation, which will set up everything in AWS console in order to integrate with Jira. You will need to install and configure AWS Service Management Connector in Jira and establish a connection. The credentials required for the connection will be available from CloudFormation templates output. So we will switch to the AWS console now to see this in action. Let's take a look at how the bidirectional integration of Security Hub and Jira Service Management works. So you will need a Jira instance with Jira Service Management installed. Then you will also need to install the AWS Service Management Connector for Jira Service Management. The instructions for doing the same can be found in this AWS page. So there is a sample CloudFormation template which will deploy all the baseline permissions, configurations, and resources required for the AWS connector using either the AWS console or CLI. There's also a CloudFormation template available for the GovCloud region. So once you follow the instructions, you will need to copy and paste some information from the output of the CloudFormation template to set up a connection and then test the connectivity. So as you can see, I have connected my account with Jira, and it's currently syncing all the findings from US West 2 region. You can add more regions here or create a brand new connection with a different AWS account. You can then fine-tune the configurations by going into the connector settings screen. Here you can choose the AWS products to integrate with Jira, such as Security Hub, Service Catalog, System Manager, AWS Config. You can also configure the specific Jira project, which will receive all the Security Hub findings once it gets created. You can choose to link multiple accounts to same Jira project or create a one-to-one mapping as well. And this is the queue which makes the bidirectional integration possible. And the name of the queue is available after the CloudFormation template is deployed. The sync interval and also the number of messages to pull from SQS at the time, it's also configurable. And there is another configuration which lets you choose if you want to synchronize only specific severity levels, such as critical or high, from Security Hub. Okay, so let's see this in action now. So here are the Security Hub findings which got created in the project that I specified earlier. As you can see, the workflow status of this finding is set as new. I'm going to update the workflow status to notified here. So here the status is updated to notified. So let's check in Security Hub. So in Security Hub, the status is now updated to notified. And in here, we will now go ahead and then update the status to resolved. So Security Hub status got updated to resolved now. And the same status is now updated in Jira as well. So the status of the finding is updated as resolved. Okay, so for tip 3, let's see how we can create auto-suppression rules for specific types of findings in Security Hub, such as the ones that are an accepted risk by design or have a compensating control in place. By automatically suppressing these findings that don't require follow-up action from your security team, you can concentrate on investigating and remediating findings that are not yet resolved. For example, suppose that your development environment does not need to have Amazon VPC flow logs enabled because it does not contain any sensitive data. So this is an example of an accepted risk. However, your production account must have VPC flow logs enabled. Then you can use this solution to automatically suppress findings from the development account and then just focus on findings from the production environment where VPC flow logs are not enabled. In Security Hub, the status of a finding is tracked using the workflow status attribute. There are different workflow statuses such as new, notified, or resolved. If the finding is not a concern for your environment and does not require any action, then you can set the workflow status to suppressed. As we already saw before, this solution also uses an event bridge rule to evaluate Security Hub findings based on predefined conditions. Using an event bridge pattern, the event bridge rule will filter findings from the development account that don't have VPC flow logs enabled and then send it to a Lambda function. At a high level, the solution works in this way. Security Hub generates findings in the member accounts, and the centralized administrator accounts has permissions to view those findings. In the administrator account, Security Hub evaluates every finding against an event bridge rule. And if a finding satisfies any of the event bridge rule condition, event bridge will trigger the Lambda function. And finally, the Lambda function sets the Security Hub workflow status to suppressed using the batch update findings API. So let's see this in action, and let's switch to the AWS console. Thanks for following me to the console. So I have deployed the CloudFormation template to my Security Hub administrator account. So this CloudFormation template takes 2 parameters. First is the account number. So I have passed my development account number where I want to suppress the findings. And the other parameter is the generator ID, which uniquely identifies the Security Hub finding of not enabling VPC flow logs in your account. So for this to work, one prerequisite is that you need to enable the AWS foundational security best practices control in the account. And it's because this specific finding for flow logs will only get generated after you enable the foundational best practices standard. So there are a bunch of useful controls available in this AWS documentation to easily get you started if you're not familiar with the AWS foundational security best practices control. So now let's take a look into the event bridge rule, which was created by the CloudFormation. So this rule will get invoked anytime a Security Hub finding is created that satisfies all the following conditions. So the rule checks if the finding has the generator ID for the VPC flow logs, and it belongs to the development account that we specified earlier, and also if the workflow status is set to new. You can customize this event bridge rule specific to your environment. For example, you can add
multiple account IDs, or use a combination of different finding generator IDs that you want to automatically suppress. The target of this event bridge rule is the Lambda function, which will set the workflow status to suppressed. So here is the Lambda function. So it receives the event from the event bridge, and it uses the Security Hub batch update finding API to set the workflow status to suppressed. And it also sets the severity to informational. For auditing and troubleshooting purposes, it writes the CloudWatch logs as well. And finally, in Security Hub, as you can see, the automation has suppressed the finding for the account ID that we specified. The automation framework is deployed in my Security Hub delegated administrator account, where I can view the findings for all the accounts associated to my AWS organization. So any update in the administration account will automatically be replicated in the member accounts as well. So the same finding and status is visible in the development account and also in your centralized administrator account.
So those are the first three ways to operationalize Security Hub. And Jason will come and talk about the other tips. Jason, over to you.
Awesome. Thank you, Prashab. I appreciate it. And let's pick it up here, taking a look at tip number 4. So here in tip number 4, we'll use Security Hub to correlate findings from multiple AWS services that are related to a single resource. So usually what happens when you see findings that are related to the same resource, it indicates an increased possibility that a security event has occurred. So let's start by walking through how the solution works. So number one, and we've discussed that Security Hub ingests findings from multiple AWS services, including Guard Duty, Inspector, Macie, Firewall Manager, IAM Access Analyzer, and Systems Manager, Patch Manager. And so then you can have an event bridge rule that gets invoked based off of some of these findings. That event bridge rule will kick off a Lambda function as denoted in number 3 that will read the contents of that finding and put the data in a DynamoDB table per number 4. And so in that Dynamo table, we're going to add a TTL value to those rows to expire those findings that are older than 30 days. And then we have another Lambda function denoted in number 5 that looks at the findings in that Dynamo table to see if there are findings that relate to the same resource. So let me give you an example. If Guard Duty detects a backdoor finding and perhaps Inspector detects a critical common vulnerability or exposure, otherwise known as CVE, on the same EC2 instance, it's pretty likely that that EC2 instance was compromised and perhaps a backdoor was installed because of the CVE vulnerability. And in this case, it's recommended that you isolate the instance and then follow your typical standard procedure for forensics to verify that, yes, actually the instance has been compromised. And then, of course, your standard incident response plan should kick in. Another example, AWS Security Hub could detect an EC2 instance with a public IP address and an unrestricted VPC security group, and then Guard Duty could find unusual network activity and perhaps a brute force attack on port 22 or SSH or port 3389 for RDP if you're running on Windows. And this would be recognized by the number 5 Lambda function, and a new finding would be generated in Security Hub for the correlation. So follow me to the AWS console, and I'll give you a quick demo of how this solution works. Okay, thank you for joining me in the console here for tip 4 on correlating Security Hub findings. So I've navigated into the console, and I'm going to show you what this solution looks like. So we'll start with CloudFormation. This is all kicked off by a CloudFormation template, and you can see that there are many resources that are defined. We have custom findings and Lambda functions. We've got KMS key for encryption. We've got event bridge rules. And so this is what gets deployed when you initially deploy the correlation stack as denoted in the blog post. So I've already pre-installed Security Hub here But what the solution will deploy are some of these event bridge rules. So I'll show you some of these event bridge rules. Here they are. I've got 4 of them that come out of the box, and you can always extend this using the framework that you find as part of the template. And so I've got one here for creating an entry in Security Hub from Security Hub for Dynamo. And then I've also got others that create entries in Dynamo from Security Hub guard duty findings or inspector findings or for Macy findings. So these are the rules that would normally get triggered. And that will kick off Lambda functions that will take the data that's fed to the Lambda from these rules and store it in a DynamoDB table. And I have a DynamoDB table here that I've been running for a number of days now that have several findings in them. And you can see that I've got some pretty good ones in here. This instance has been involved in SSH brute force attacks, for example. And we know that that came from guard duty, and it shows guard duty as the generator ID here. And it also shows me, where it was, the region that it was in, the AWS account that it was part of, and what kind of severity it is. Now, this one's a low severity, but I have several high severity findings in here, as well as the details about the finding itself. So this is the detail that you would normally find in Security Hub. And so now that I've got all of these findings in here, we want to create a custom finding for in Security Hub for events that match the same resource ID in this Dynamo table. And here is my Lambda function to go and do that. You can take this code and modify it any way that you want to extend it for other types of responses. But when this function will actually run, it's going to write to the logs. And I want to show you some of these logs. I want to walk you through one that I saw a couple days ago. And so here, we're searching a DynamoDB for this specific instance. We're going to have these 3 checks. So the first check is, Security Hub exposed IP or unrestricted security group, and a guard duty finding for an unusual network port and brute force attack on this instance. We found it. We found that there was actually a finding in Security Hub with the public IP. We found that it was, in fact, a brute force attack, but we did not find any other matches here. And then we'll go on to our second check for S3 data exfiltration. We found no matches. We check our third check for guard duty, looking for a backdoor that may be installed with some critical CVEs, and again, found no matches. And so in this example, we didn't find a match, but if there would be a match across multiple resources, that would be fed back into Security Hub as a custom finding, and something that your incident response teams should definitely take a look at. Moving on to tip number 5. Here in tip number 5, we'll deploy CloudFormation templates that are referenced in the QR code link in the upper right to create the remediation playbooks using CloudWatch events, Lambda functions, and AWS Security Hub custom actions to respond to findings in the AWS environment. So this will allow your security analysts to respond to those findings by triggering an action. And just to be clear, this doesn't actually automatically respond. A human is still going to have to click the remediate button, but that human won't have to figure out what to do to actually remediate. It will be included as part of the playbook. And so this diagram will walk us through the various steps needed for on-demand remediation, starting with detect. And so, we've talked about it a little bit before. Security Hub will gather all of these findings across your AWS organization, and then you can trigger CloudWatch logs rules to be invoked to invoke Lambda functions or step functions for findings that are of interest. And so when you click the remediate with char button in Security Hub after deploying the process, you'll be ingesting the finding detail into a Lambda function or playbook using this CloudWatch event rule. And then the playbook or the Lambda can assume a role into a managed account and automatically remediate the finding. And of course, we want to log this. So anytime that we run an automated action, this data and that event will be logged in CloudWatch logs. There are remediation playbooks for the CIS best practices, AWS foundational best practices, and PCI DSS. There won't be automations for everything, but there will be for a good majority of the findings. And a good example might be if Security Hub detects the EC 2.7 finding in the AWS Foundational Best Practices Playbook, which is that EBS default encryption is not enabled. So if you don't have a default encryption enabled in your account, this could be a finding. The remediation that can be executed will enable EBS encryption as the account-wide default. Now let's break to a demo and walk through some of the playbooks and actually remediate a finding live. Okay, folks, for tip 5, you can join me in the AWS console and the documentation. So we're going to start, I'm going to show you the different playbooks. So these playbooks, as part of the AWS Security Hub automated response and remediation solution, includes a number of different playbooks, and it will cover the CIS best practices. It will also cover the AWS Foundational Security Best Practices playbook, and it will also cover the PCI DSS playbook. But I want to give you a couple examples here. If we look at some of the foundational best practices, you can see the automated action that SHAR will take. So a good one here would be, EBS snapshots should not be public and determined by the ability to restore from anything. So if you were to discover this in your own AWS account in Security Hub, SHAR could remediate this by making all EBS snapshots private. The one I'm going to demonstrate for you here is EC2.2, where the VPC default security group should not allow inbound and outbound traffic. And so I'm going to go ahead and execute this and show you that it does remove the rules in the default security group that is the subject of the finding. So let's go to the AWS console. Here I'm on my AWS console. And first I'm going to show you what is deployed by the remediations solution. So if I go to CloudFormation, you can see a number of stacks here. This AWS SHAR deploy admin, I've got an orchestration stack, nested stacks, and I've got another stack that actually deploys all of the playbooks for the areas that I want to go and remediate. So let's go to Security Hub. I'm going to show you a finding. And here in my findings, I'm going to go ahead and take a look at this one. It's EC2.2, EC2.2. The VPC default security group should not allow inbound and outbound traffic. And so if I click into this, I can get all the details about this finding, where it is, what AWS account it is, the resource ID, and I'm going to go ahead, I'm going to show you that security group is unremediated. So let's take a look at it. Here it is, 7EF. You can see I have all traffic inbound, I have all traffic outbound, and according to the Security Hub AWS Foundational Best Practice Standard, this is not a good practice. So let's go ahead and remediate this. So I'll go to Actions, remediate with SHAR, and we should see a green banner at the top. Okay, it successfully sent the findings to Amazon CloudWatch events, and so the automation has been kicked off. Let's go take a look at the security group now. Have these rules been removed? Okay, and after a few minutes, we found that for this security group, we have no security group rules defined, both on the inbound and the outbound. So it works. Tip number 6, Security Hub and visualizations of those findings in a BI tool and a business intelligence tool. So this blog is going to feature 2 different ways to visualize your Security Hub posture and findings. Option 1, shown here, will use the centralized security account that will run Security Hub for the entire organization. And so what will happen is this account will publish those events to EventBridge, very similar to patterns we've already talked about. EventBridge will have rules that will deliver the finding types to Kinesis Data Firehose. Kinesis Data Firehose in this example acts as the data streaming service that will automatically scale with demand and move data from one point to the next. In this case, Firehose here is configured to deliver the data to an S3 bucket. If you happen to have multiple AWS regions, you can create multiple Firehoses to consolidate those findings into a single regional S3 bucket. Your S3 bucket will want to be partitioned. You want to partition, for example, based off of AWS account number, region, perhaps the date and time. And then on the other side of the bucket, you'll create an AWS glue crawler. And so this glue crawler will pull the metadata and the schema from the data in the S3 bucket. And then you could plug in Amazon Athena to query the data in the bucket using the schema pulled by the glue crawler. Then you can build your own QuickSight dashboards using the views created in Athena. Some good examples, you might want to create views based off of account, or findings by region, or findings by severity, findings by resource type, or by the workflow in the account. Alternatively, there is another option inside the blog where you can deploy this using Elasticsearch and Kibana. So if you're more comfortable and familiar with Elasticsearch and Kibana, check the blog and you can see how to deploy it in that type of environment. So let's take a look at some of the examples, example visualizations that you can create. And so here, looking at some of these visualizations, we can see the findings by resource type, or for example, the findings by date created, or for example, the findings by severity. And you can choose to create any type of visualizations that you'd like. Moving on to the final tip. Tip number 7, configuring weekly summary emails. So in this example, there is a template as part of the blog post in the upper right that you can execute that will set this up for you. And so what this will do is Security Hub will notify account owners, AWS account owners, with a summary of existing security findings to help them prioritize corrective action. And so why is this important? This is important because often cloud security processes are different from traditional on-premises security, and that in the cloud, security is often decentralized. Traditional on-premises security operations are usually centralized in a security operations center. With cloud security operations, it's often the application teams or the developers that are best suited to triage, investigate, and remediate these security alerts. So sometimes we call this DevSecOps or shift left. Centralized security teams, in this case, they'll look for additional ways to proactively engage application team owners, but empowering application teams to take action on their own security events is a great way to accelerate. So this solution is going to use Security Hub Custom Insights, AWS Lambda, and the Security Hub API, and works using these 5 steps, very similar to some of the steps we've talked about before. So 7 new Security Hub Custom Insights will be created for you from the solution. So you get those out of the box. And then a CloudWatch time-based event will execute a Lambda function that will read the contents from those custom insights, and then formulate that text into an email, and then use the SNS service, the simple notification service, to send that email to the recipient of the AWS account, and you'll be able to configure that when you deploy. Now let's break for a demo, and you can see an example summary email in action. And thank you for joining me in the AWS console. I'm here logged into one of my downstream AWS accounts, not my security account with Security Hub running in it, but the one, an AWS account that actually has workloads running in it. So here I've logged in here, and I'm going to start with showing you the CloudFormation stack that is deployed from the blog post to actually enable these weekly summary emails. So I'll go to CloudFormation, and you can see the stack name. It's called Security Hub Summary Email Stack, and a number of things have been deployed, including custom insights for Security Hub. We have a Lambda function. We've got an SNS topic to send those emails. So let's take a look at some of these custom insights. We go to the Security Hub console, and I've already pre-filtered it based off of that it's called summary. And you can see some of these summary emails here, along with a 90-day finding trend for each. And so these are the custom ones that are going to come with this solution. And at the end of every week, as an account owner, me keeping track of the Security Hub findings that are in my account, I'm going to get a summary email. And so here's an example of a summary email with the foundational security best practices checks, the total checks that passed, the total checks that failed, with some convenient links embedded in the Security Hub summary report that take me directly to some of these findings. And I can scroll down and I can see the top 10 resource types by findings. And then I also get these convenient links. So if I go on and click on one of these links, it'll open up a new tab in my browser. And here you can see that link took me directly to Security Hub, where I can get my compliance status. I see that I have 591 that have passed and 280 that have failed. as well as additional detail about the severity label, the AWS account ID, and that's my account ID, the resource type, the resource ID, and so on. So it's a great solution that you can deploy so that your account owners can take ownership of the security findings in their account and help them prioritize and take action. And thanks, team. I hope this has been informative, and let's open it up to some questions.